So the topic today is alternative sources for mobility, opportunities and challenges. Mr. V. Mallikarajuna Rao, Assistant General Manager, Advanced Engineering, Ashok Leyland.
Thank you all for giving this opportunity, sir. So today our session is on the alternative sources for mobility, opportunities and challenges. So we'll start with the agenda first. So in this session, we will go through the alternative sources. Why alternative sources for mobility? First of all, we'll come from the beginning, like, why we should go for alternative sources. What is the trouble with the current sources? So we'll discuss the why part. Then we will go, what are all the alternative solutions available for mobility? The mobility mode and alternate energy. There are two different aspects, the alternative sources. So we'll go through those two in detail. Then we will see the mobility mode, the currently how it is there, in the future how it is going to be there. So some kind of a landscape of the mobility mode. Then we will go in detail about the alternative energy sources that are available for mobility. What are the opportunities and challenges with those? Meaning the electric vehicles, hydrogen ICE vehicles, hydrogen ICE engine vehicles, bio and synthetic fuel vehicles. These are the four main alternate energy that is available currently, and the research is going on, meaning the development is going on. Then we will see the electric vehicle types, how they work, little bit in detail. Then electric vehicles major manufacturers in India, and what are the currently being produced, where we are, current status. Then we will see the conclusion, then future outlook, how it is going to be. Again, the question and answer sessions we can have, right? So let us start. So the alternate sources for mobility. So why we have to go for alternate sources? What is the current trouble that we have? So these are the two troubles mainly we have. One is energy independence, meaning currently a lot of money India is spending towards importing the fuel. We are spending a lot of money. You can see the details here. We are spending a lot of money, lot of oil, crude oil we are importing, and it is growing year on year. It is increasing. So this is a kind of putting our the expenses more and more as the year is progressing. So this is the first reason that we should go for a alternate sources instead of depending on the crude oil. Can we leverage something which is available in India instead of putting a lot of money to the other countries? So this is one that is called energy independence simply. Then the next one is pollution. So we are generating every day when we take our car or bike or whatever bus that we travel, it is emitting a lot of carbon dioxide, which is the carbon dioxide, which is a kind of a pollution, right? So this particular one is you can see the graph here. Every year the amount of carbon dioxide that is emitted, it is going on increasing. It is not only from the automobiles but also from the industries, a lot of other things, construction, all that together. But automobile roughly contributes, I think, 25 to 30% for the emissions. So the carbon dioxide reduction is also main. So these are the two aspects. One is energy independence, other one is the pollution, right? So we'll go through a little bit details on the what particular carbon dioxide, why it is polluting so much. So you can see this particular slide where the sunlight that is coming from the sun to the earth, the earth is reflecting back the radiation to the space. But when the presence of the carbon dioxide in the atmosphere, the carbon dioxide again reflects back to the earth. This is the reason the earth temperature is going to go up. This is what is called the greenhouse effect, or the climate change. So because of this particular carbon dioxide going, CO2 going up every day, the temperature of the earth is rising year on year. So if we move this way, the temperature of the earth, the total climate change is going to happen, and the temperature will go up like anything. That's the reason we have to reduce the carbon dioxide emission, and that means we have to make it zero. That means whatever carbon dioxide that I'm emitting, I should take back from the environment. That's how the particular policies are moving towards. This is the main reason that the carbon dioxide reduction is required. And also you can see the right side, the carbon dioxide emissions per person. For example, the different countries, of course, per person, India is less, but because of population, the total amount of carbon dioxide that we are emitting is also considerably high. The China is much more, the US, all the other countries are like this. So this is the area of rectangle shows the total the carbon dioxide that is emitted. Okay, x-axis is population, y-axis is the tons of CO2. So this is how the important aspect is to reduce the carbon dioxide emission. Then you can see one more pictorial way. Suppose if we go in the same direction of carbon dioxide emission year on year, by 2100, it will be like 5 degrees, 4.1 to 4.8 degrees of temperature will rise. That is kind of very high rise in temperature. So therefore there are policies are in place which will make sure that we are not increasing it by 1.5 degree. So these are the different pictorial ways showing that the carbon dioxide, how to control that. This is the reason actually behind the alternate sources. So there is a Paris Agreement that you might have come across in the news. Then the greenhouse gas emissions must be reduced by 43% by 2030. That is the first target, and it should reach net zero by 2050. By 2050, there is no carbon dioxide emission from any of the human operations. That is the particular policy that is signed by many countries, including India. So this is the like little bit background on the why alternative sources are required. So let us say we summarize this. One is energy independence. So that means protecting our own money, which is not going out from the country. Therefore, our economy is developing. Right. The next one is emission, like pollution, air quality index that you see every day in news, the carbon dioxide, the climate change, all that. So that is the next one. So emission reduction. You can see that the 2047 is a target for becoming energy independent. That means we should not import anything further by 2047. That is the Prime Minister set target. Then you can see the national green hydrogen mission. This is also in line with the Paris Agreement. What is the further level, like a drill down targets? What are the drill down targets? 5 million metric tons per annum green hydrogen production, and 50 million metric ton per annum CO2 is to be reduced from every year, 50 million metric tons of CO2 reduction. Then there are renewable energy that is going to be 125 gigawatts of energy addition, then jobs, and then the investments, all that is there. So this is the brief background of the why alternate sources are required for mobility. What are the alternative sources for mobility? So what are the sources? Now we discussed previously why we are doing this: energy independence and emission, the pollution reduction. Then what are the ways that I can achieve this particular one, like energy independence or the emission reduction? How can I achieve? There are two ways again to achieve that. One is alternate modes of mobility. Alternate modes of mobility in terms of, okay, can I avoid car taking, or can I avoid taking the bike, or can I walk? That is just obvious one, the walking. Then carpooling. Instead of taking my car every day, can I join with friends and do carpooling? Ride sharing. Can I just put the recent apps that if people are traveling by car to the office, they can actually do the ride sharing and pick up few other people, even the strangers as well. There are apps that are allowing this, right? Then robo taxis. So the taxis which are automated fully, like what we have discussed, artificial intelligence, the machine learning, all that part goes into this robot taxis, and they navigate in the way people, and they commute the people from one place to another place. So these are the different alternate modes of mobility that one can use. Therefore, I can reduce the or as a country we can reduce the fuel usage. Therefore, the emission will come down, or therefore imports also will come down. So this is one way, but this is alone is not going to help. How much ever we try, sometimes it is not possible to do this carpooling or whatever that is discussed so far, alternate modes of mobility. Then what is the next one? The alternate energy for mobility, meaning can I use, instead of diesel, petrol, can I use some other fuel which is green? So these are the ones that are available, that are being tried now: CNG, LNG, hydrogen, hybrid, then electric. So CNG, to some extent you might have heard already in the particular whenever you are commuting, you might have heard this: CNG, compressed natural gas. LNG is liquefied natural gas. So same natural gas, but in terms of liquid form. That is the LNG. Then hydrogen, which is just picking up hydrogen. Electric, to some extent, electric is already available, and people are using these electric vehicles currently. And hybrid. Hybrid also not fully green, but it could be a stopgap arrangement. So it could bridge the gap between where we are currently to where we want to go into future. The hybrid vehicles can bridge that gap. So these are the sources and classified into two aspects. One is mobility, and the other one is alternate energy. Different modes of mobility and alternate energy. Then what is the landscape of current and future mobility mode? The first point that we discussed. Where are we in terms of this is particular a research or the survey result where it's a global result from this company McKinsey. There are 45% of the the movement mobility is happening by private car currently, and 23% is by traditional public transport, then 16% walking, 14%, sorry, 16% micro mobility in using two-wheeler or the kind of three-wheeler or very kind of micro kind of things. Then the 14% is walking, then 2% only is ride sharing, then 1% new forms like robot taxi, all that. But this particular landscape is going to go, and this is coming from different people, the interviews from different people, and also different mindset, based on the people telling, no, I want to save, I want to be green, so I won't travel by private car, I'll, instead of using that, I'll use public transport, like that. So this public transport is going to go up a little bit, then private car usage will come down. Then micro mobility, suppose if being metros developing a lot, then people try to use some two-wheeler or something to reach metro station and then travel. So we observe this daily actually. So this is what summary being shown here. So therefore there is a push towards this alternate mode of mobility using. That is what this particular slide talks about. Then what are the different mobility, the energy sources? The second part that we discussed, how to reach that alternate energy, or how to reduce this emission, or how to be energy independent. The second part is the energy sources. What are the energy sources that we have for mobility? What is the past energy sources that we have, current and future? We'll discuss those part. In the past, in the past we had the animal power, like horses, that moving the people from one place to another place. People are goods. So in this case, when I say transportation, both people and goods. Then we had this wood, with burning the wood. Then we have more coal based, like the steam turbine kind of things, steam engine kind of things, where the steam is used, coal is used. Then we come to the petrol and diesel. So these happened over a period of time, like 19th century, then 20th century starting, the petrol diesel came in. Now currently we have got petrol diesel, which is also running. Then we have got ethanol mixed with petrol. So the petrol mixed with E20, you might have heard this E20, 20% of the 20% ethanol is mixed in the petrol. Therefore we are reducing the imports and also making it little bit more greener than what it is currently. Then the biofuels, ethanol, then remaining all biofuels is currently being used. Then we discuss that CNG, LNG, natural gas is being used. Then electricity. These are the current being used. So you can see these petrol, diesel, still it is there, and it is there to greater extent currently. Therefore, in the future, what we don't know about the future fully, but what we expect the future to be: electricity, hydrogen, and carbon neutral synthetic biofuels. These are the three things which may be coming into the future. And it is already started, the transition already started. We are in the transition phase where we are using the conventional fuel or also the new fuels. So if we see the vehicles that are running on the road, now we have got a lot of varieties of fuel, right? So but in future we will come down and we will reduce to the greener fuels. Okay, so we'll discuss about the opportunities and challenges for the electric vehicles. So we discussed previously in the previous slide that the future is going to be electricity, hydrogen, or carbon neutral synthetic biofuels. So we'll discuss more about opportunities and challenges for this part, future part. Okay, so the electric vehicles. So the electric vehicles mainly these work on the using the battery. So you can see the energy flow, electric vehicles, battery, motor, then gearbox, rear axle, wheels. So this is the energy flow path for the electric vehicles. So therefore, the electric vehicles are like there is no internal combustion engine, there is no much moving parts. Therefore, we get better efficiency. And the battery charging, if it comes from the renewable sources, then it is fully green, kind of well to wheel, fully it is green. But currently some of the charging systems are all running by coal, but in future the kind of every source coming from the renewable energy, that time we'll have full green mobility. Right. So the opportunities in terms of electric vehicles, there is no emissions, zero emission, no tailpipe pollutants. Lifetime cost, kind of maintenance and fuel, as we discussed, the number of moving parts are less, therefore maintenance costs are less. The fuel is also less because we are not importing here, we are making the fuel ourselves, therefore the cost will be less. So the integration with renewable energy grids, this is what we discussed, the energy where it is coming from for the charging system, that is also important. The challenges for the electric vehicles, the challenges are high upfront cost. For example, to buy the same car, diesel versus or petrol versus the electric will be slightly costlier now because of the battery cost. As if you see the battery cost in the past 2-3 years versus now, battery cost has come down, but in future still further coming down chances are there. Therefore by maybe another few years we will have the petrol vehicle or electric vehicle the same cost. Therefore current challenge is how to reduce the battery cost, how to make battery more reliable and more durable, meaning it is going to long last as the ICE engine is. So those are the current challenges that we have in the industry. Then limited charging infrastructure. The charging infrastructure, like every street has a petrol bunk, right? So you see sometimes 2-3 petrol bunks lining up one after the other. But the charging infrastructure, do I have enough charging infrastructure? Can I go and charge it wherever I want? If I traveling from one city to another city, how many charging stations are there? These are the things that has to evolve. The government initiation or the collaboration is required to move towards the better infrastructure. Then the range is, in a single charge, how much kilometers I can travel in a single charge. That is what is called range. That is the bottleneck currently some people have, not everybody. That if I start from my home, can I reach something like 500 kilometers, 300 kilometers? Like that people are thinking, because the infrastructure is not available. Suppose if infrastructure is available and I can charge everywhere, then the range concerns will come down. Therefore these are all linked. If the charging infrastructure goes up, the range concern will come down. So this is the brief opportunities and challenges for the electric vehicles. Then we move on to the hydrogen fuel cell vehicles. So the hydrogen fuel cell vehicles, the opportunities, again, hydrogen fuel cell vehicles, the fuel is hydrogen. Then the hydrogen goes into something called fuel cell. The fuel cell will convert the hydrogen into electricity directly. So this fuel cell is a device which takes input into chemical format, that is a chemical form, that is input energy is in hydrogen chemical form. The output is electricity directly. Whereas the engine, if you see regular internal combustion engine, it takes the diesel as input, which is chemical energy, but the output is mechanical energy, which is a flywheel rotation. But in this case, the electricity comes out directly. The same electricity is given to motor, therefore motor to gearbox, rear axle, and then wheels. Wheels are driven. This is the energy flow path for the hydrogen fuel cell vehicles. So the hydrogen fuel cell vehicles, they produce electricity, something called electrochemical reaction. That is the kind of science behind it. Then what are the opportunities? Again, this is also zero emission. The exhaust is only water. The water is going to come out. Electric vehicles, nothing comes out, the exhaust. But whereas in hydrogen fuel cell vehicle, the exhaust pipe will be there. In that, instead of you see in the diesel vehicles the smoke coming out, right? Instead of that, the water comes out, water droplets comes out. Another good opportunity in terms of with respect to electric vehicles, this is fast refueling. The refueling or the recharging, you call, in terms of electric vehicles, the refueling will be faster. Like I go to petrol bunk, I just fill full tank, let us say in 3-4 minutes maybe, right? In the similar way, the hydrogen can be filled very fast, but not as fast as the diesel, but very kind of at par with diesel. But it is much better than electric vehicles. Of course, electric vehicles do have megawatt charging kind of thing, where we can really charge very fast. Within half an hour, it reaches from 20% to 80% of the battery state of charge, right? So both are there, and both will be having specific applications where it will suit aptly, the hydrogen vehicles and electric vehicles. The challenges in the hydrogen is hydrogen production is a main challenge. Like it is very energy intensive for producing the hydrogen. There is a, like electric vehicles, this is having limited fueling infrastructure. Then high cost of fuel cell vehicles. So you can see that the battery electric vehicles having motor, battery, all that. The hydrogen fuel cell vehicles also having the almost the same components plus fuel cell and hydrogen tanks. These are currently very costly and imported things. So therefore, the currently high cost is there. That is the main challenge for the hydrogen electric vehicles, hydrogen fuel cell electric vehicles. The next one is hydrogen IC engine vehicles. Hydrogen IC engine vehicles is similar to current IC engine vehicles, but instead of the diesel going into the vehicle or petrol going into, in case of cars, the air and petrol mixture, instead of that, the hydrogen and air will be mixed and sent to the combustion chamber. So the hydrogen will go into the IC engine, then the power is produced, mechanical energy is produced, therefore gearbox, rear axle, wheels. That's how the energy flow path will be. So the hydrogen, this is also under research actually right now. The hydrogen engines are being developed. Therefore, the hydrogen when it comes, it can be used for hydrogen fuel cell and hydrogen IC engines also. But hydrogen fuel cell needs little bit more the quality of hydrogen gas, whereas hydrogen IC engines does not need that much quality. For example, to put it in a numbers, 99.97% quality is required for the fuel cell vehicles, but the IC engine vehicles, that much is not required. I'm not sure about exact number, but it is lesser than that. So the opportunities in terms of the hydrogen IC engines, the lesser initial vehicle cost, meaning it is just a little bit to change over the existing. Therefore, it will be lesser cost compared to FCVs and faster refilling time, like that discussed previously. The challenges and challenges is mainly it is not fully green. It is still having some emissions. Some pollutions are coming up from these vehicles, and therefore this can be having the less cost and still having some emissions. It could bridge the gap between where we are currently to the fuel cell vehicles. So before probably mass adaptation of fuel cell vehicles, these hydrogen ICE vehicles can actually fill a lot of gap. Therefore, we slowly transition to the fully green. Of course, limited fuel infrastructure. Currently, there is no filling stations available. Very limited, very limited. And the hydrogen production is energy intensive. So these are the challenges for the hydrogen fuel cell vehicles. Then we come to bio and synthetic fuels. The bio and synthetic fuels, it is like the existing fuels, for example, but the fuel is made by taking the carbon dioxide which is available in the environment. For example, we kind of take carbon dioxide, use the photosynthesis process and build a lot of farming kind of thing and produce biofuel from the farming or the basically from the field. So this biofuel is used in the vehicle, therefore the carbon is coming out and this cycle will continue. That means whatever carbon dioxide that is coming from the vehicles will be converted back to the fuel, the same one. Therefore, at least there is no extra emission. So this is the concept of the biofuel. Then synthetic fuel, where the carbon dioxide again taken from the environment, and the between using a green fuel, there is a synthesis happening and then fuel comes out, synthetic fuel. That fuel will be used in the vehicles. So this is how the cycle will happen. But there are some challenges to it, meaning high production costs is a major challenge. Then energy intensive, limited scalability. So these are the main challenges for that. But there are opportunities using that. It will be renewable, obviously, and also fossil fuel dependency will be coming down. These are the opportunities in that. So that is about the different alternate energies we have discussed. We'll go in deep about the electric vehicles and we'll just see what are the different electric vehicles that are available currently in the market. There are battery electric vehicles, hybrid electric vehicles, plug-in hybrid electric vehicles, and fuel cell electric vehicles. These are the 4 different electric vehicles available. BEV, simply called BEV, or full electric vehicles. Simply there is a battery packs and electric motor. So the battery is the one which is having a lot of energy stored in chemical form. Then the motor takes that energy, then converts it into the mechanical energy. This is how the simple battery electric vehicle is there. Then hybrid electric vehicle, there is a fuel tank in terms of maybe diesel or petrol, depends on the vehicle. Then there is an engine also drives the rear axle. Motor whenever there is a kind of low demand, the motor will run and it will store the give the energy to the battery. And where is a more demand, the motor also will help the engine to drive the rear axle, meaning both motor and the engine will drive. In case of plug-in hybrid electric vehicles, the battery also can be charged. These two are almost same. Here battery cannot be charged. Here battery can be charged from the external charging port. You can see that symbol here. The battery can be charged. Here the battery is not charged. Otherwise both are same. There is a fuel tank, there is an engine, there is a battery, motor. All the things are same. Just that plug-in is called because the battery alone can be charged externally. So mainly these kind of things will be used in case I want to run in battery mode alone. I come back home, then charge the battery, again I run. So for example, for small commutes. So whereas the long distance, if I travel, then probably the fuel tank will be filled and it will be traveled. It will be driven to the long distance. That's how these two hybrid vehicles work. Then the last one is fuel cell electric vehicle. This we have already discussed this. Hydrogen tank, there is a fuel cell. The fuel cell will produce electricity. That electricity will go to the motor. Then there is a battery. The battery also will supply electricity to the motor whenever there is a more demand from the rear axle. Suppose we are climbing gradient, or when there is a overload on the passengers, all that. And whenever there is a brake applied, this is one of important aspect, something called regeneration. When there is a brake applied, the motor will act as a generator and it will produce electricity. That electricity will be stored in the battery. That means we are using the inertia of the vehicle to get back some of the energy. Instead of wasting as a heat, we are just storing it into the battery. So that's how these vehicle will operate. Yeah, this is the electric vehicles major manufacturers in India. So you can just, this is to give you a feel of what are all the kind of electric vehicles that are available currently, just for a kind of to give you this many OEMs are working on the electric vehicles. So you can see that this is two-wheeler. You might have seen on the road as well, Ather, a lot of other OEMs are there, Ola, like that. But this is slightly older data. You may have actually more than this currently. Then we have got three-wheelers. There are a lot of three-wheeler manufacturers as well. Then we see the four-wheeler. You can see the four-wheeler, of course, this is 2021 data. There are many more coming up in terms of, but you can see in the news as well, Mahindra and Tata Motors mainly leading a lot of electric four-wheel cars, right? Then we see the major, the commercial vehicles aspect. Commercial vehicles, Tata Motors, iShare and Ashok Leyland. These are the three main. Of course, Bharat Bench is there. Just for the interest of time, I have covered these three. So we'll discuss more on the commercial vehicles, what is happening in the industry. So you can see that here in the Ashok Leyland Auto Expo 2023, Ashok Leyland presented only the alternate fuel vehicles. So there was no diesel vehicle in the stall. So you can see here the hydrogen internal combustion engine, liquefied natural gas vehicle, then the CNG vehicle, 13.5 meter intercity vehicle, then hydrogen IC engine, vehicle. Sorry, this is battery electric vehicle, the first one, the 14 ton smaller part of it. Then fuel cell vehicle. Then one more CNG vehicle for the passenger application. So these are the different vehicles that are there. Then iShare do have all the fuel, the advanced fuel, alternate energies. Then Tata Motors also having the similar vehicles. So this is the kind of a landscape currently. The OEMs working towards the alternate vehicles. Also the kind of government companies, for example, different energy suppliers like IOCL, NTPC. These people are asking for the vehicles to do the hydrogen trials. To do, for example, MNRE, there are some programs running in MNRE to see the charging infrastructure, how it is there in the complete in India. So for this, the kind of pilot trials are currently going on. So this is how the kind of, after the pilot trials are going on, the mass production scope is there. So these are the OEMs that are working. Any clarifications, please let me know. I'm pretty much done with the session. meaning the main slides. If any queries, you can ask. Otherwise, we will go to the conclusion and feature outlook. Well, the conclusion, yeah.
Sir, out of the fuel cell and hydrogen energy, which one is the productive? And also, what are the challenges we are facing while using the hydrogen as well as the fuel cell?
So the query is
Sir?
the comparison between hydrogen fuel cell vehicles and hydrogen ICE vehicles, ICE engine vehicles, right?
Yes.
So the hydrogen fuel cell vehicles, as discussed earlier, the cost of the hydrogen fuel cell vehicles is high currently because it involves the high voltage battery. Also, it involves the fuel cell. So as the technology advancing, the fuel cell cost can come down. Battery cost also can come down. That time, these will be kind of at par with the hydrogen ICE vehicles. But the hydrogen ICE, in terms of hydrogen ICE challenges, the engine development is not fully over yet. Kind of the research is still under progress in terms of the knocking, the complete power production, torque production. Those research is currently going on in terms of hydrogen ICE. But the efficiency point of view, the fuel cell is having better efficiency than hydrogen ICE, meaning the fuel cells of the order of 40 to 60% efficient, whereas the IC engines are below 35, or best is 35 to 40 maybe. So that's how the fuel cell technology may be also, as we discussed earlier slide, hydrogen IC engines are still having a little bit of emission in terms of NOx. These are not fully green. Therefore, it may take time for the fuel cell to pick up, considering the cost aspect and considering the efficiency is good. But hydrogen IC engines, if the research and development is happening in the next 1 or 2 years, then they can bridge the gap. So that's what the fuel cell and hydrogen ICE. So one more thing you asked on the challenges of what exactly that is. Could you please repeat? This is the comparison what we discussed.
Yes, while using fuel cell and hydrogen.
Okay.
And also, I think voltage is very less, no, sir, in hydrogen fuel cell. Whatever the voltage is generated, I think it's too less.
So usually the voltage that is developed in the fuel cells, it is order of 300 volts. Yeah, and anyway, that will be boosted up to whatever required, like 650 volts. It will be boosted by using DC-DC converters. Then that will be used for the motor. So that's not a big challenge in terms of voltage point of view. But the challenges in terms of fuel cell vehicles is a cooling. Like you all know that IC engines we cool, and the radiator is main part to cool the IC engine. Similarly, fuel cell also develops a lot of heat. When the chemical reaction is happening for the hydrogen getting converted to electricity, there's a lot of heat generated, and IC engines are having a lot of moving parts, friction, all that takes away the kind of energy. But in this case, whatever is lost, that is going in terms of heat. Therefore, for every 1 kilowatt of energy that is we are producing, there's a lot of heat. 40% of that goes as a heat, pure heat. There's no friction. So that heat taking out is a very challenging part. Therefore, the sizes of the radiator will become big. Then the fuel cell is producing the electricity directly. Therefore, the coolant which is going close to the fuel cell should be non-conductive. Water is conductive basically. The coolant is also conductive. But in this case, special coolants are required which are non-conductive kind of thing. So that's why these are challenges in terms of cooling part.
Yeah, what about
is that answering your query?
What about membrane, sir?
Yeah, membrane is materials also. The exactly whatever cost that we discussed, it is mostly goes into the membrane material, membrane coating material cost. So polymer or proton exchange membrane or polymer exchange membrane, like that we call proton exchange membranes. The membrane is the costliest part, and yes, research is going on to reduce that. But currently, most of the OEMs are kind of importing the fuel cell. But few OEMs, like few companies, I know the IOCL, I think, is doing the research on that in Delhi in the fuel cell.
Yeah, even IAC, even HP, many are doing so. But the only thing
Yeah.
is, membrane. Many companies not supplying. Only 2 companies are supplying for membrane. That is a major challenge with the membrane.
Okay, nice. Yeah, as you told, yes, there can be many other, the kind of academic or industry things doing.
Yes. Sir.
Yeah,
A
fuel
lot of
cell research,
collaboration with
definitely.
even
Yeah,
companies, HP and
correct,
other companies.
correct. I agree with you.
Answer. Anyway, thanks for the presentation, sir, because it's a wonderful talk I have seen from the beginning.
Yeah. So
as it's
yeah,
an introduction, also you have covered a lot on introduction. So thanks for the presentation.
Thank you for that. So when we go to the conclusion part, then we'll open up for the further questions, more and more questions, if any. Then basically the transition to clean mobility, the climate change that we discussed in the beginning, right? So 2 aspects. So why we are doing all this? 2 aspects, mainly the part of energy independence and the climate change. How can we avoid this climate change and be the kind of protect our environment for the future? So that is the part. That's why we are doing this transition. And technological advancements in terms of battery, hydrogen infrastructure, of course, the artificial intelligence that is coming up, that is going to be very useful in terms of failure prediction. There are a lot of applications for the AI that everybody must be coming across already, right? So coming from seeing from your mobile, face recognition, a lot of things. So probably nobody in this probably industry who have not come across AI. So definitely one or the other way would have come across AI already. So I'm not talking much on that, of course. Then collaboration among the government, industries, and consumers, as we discussed, that the development, the ideas exchange, those will be crucial for the further success of this. So I'm just now open for the question and answers.
Dear participants, the session is open for Q&A now. You can ask your queries.
Sir, for the sake of participant, I'll ask you a question.
Yes, sir.
Sir, actually, nowadays there are hydrogen vehicles are there, means to say they're using an IC engine. So what kind of percentage they're using an IC engine, sir? Any percentage? Means to say efficiency percentage. If I'm going to talk about.
What exactly, sir? What you told?
So there are IC engine vehicle nowadays. So they're using IC engine only with hydrogen. What's the percentage of hydrogen they're using in IC engine, sir?
Okay. Actually, the IC engines with hydrogen, as far as I know, actually not launched by any OEM yet. The product is not available for buying outside currently. It is still under research, sir. But there are some 20 to 30 vehicles are run by Reliance Industries, because there is no hydrogen fuel available outside. Meaning the commercially hydrogen fuel is not available yet, and it is very costly. Even we have to buy for research, it is costly currently. So therefore, the infrastructure has to develop, and then the kind of product launches will happen. Currently, it is in kind of a proto testing phase, sir.
Okay, sir.
So
thank you.
Thank you.
Sir?
Yes, madam.
Sir, regarding fuel cell powered electric vehicle, the power output of fuel cell is very less. In that case, you say that you will be using a DC to DC converter in between in order to boost the power. Which power converter is preferable? Which type of DC to DC converter is preferable in that case?
Okay, the fuel cell power is kind of order of let's say 80-100 kilowatt, but there is a battery high voltage battery which will supply energy to the motor whenever there is a high demand. But what I think your query is, fuel cell voltage is less, therefore we boost the voltage. So it's not power that we are boosting. Definitely power cannot be boosted. The voltage that we are boosting with the DC-DC converters. So the exact the details, what kind of rectifiers or something will be used inside, I'm not aware, but the simple DC-DC converters are used to kind of step up the voltage from 300 volt to 600 volt, approximately 2 times.
So in that case, we can use a simple boost converter to boost the voltage.
Correct, exactly.
What
Simple
I mean
boost
to
converter.
say is, you cannot boost the power, but when you are boosting up the voltage, at the same time current will be stepped down.
Dropping. Right,
In order to match
Exactly.
the power rating of the input and output.
Correct. The current will be half of that input current. Yes. So the kind of the voltage is doubled, current will be half. So that kind of DC-DC converters only we are using.
Okay, sir. Thank you.
Yes, madam. Yes, correct. Therefore, while developing these fuel cell vehicles, the capacity matching between fuel cell power and battery capacity, these two are carefully studied so that we don't spend too much money on the fuel cell. We kind of optimize the battery size so that we meet the application. Otherwise, if you see the kind of the engines that we have currently, let us say 300 HP, like that engines are there. But when it comes to fuel cell, the 160 HP itself is enough. So that's what I want to say. The power of the fuel cell will come down because there is a high voltage battery which is supporting the fuel cell for running the vehicle. Okay.
Excuse me, sir. Good evening. Am I audible, sir?
Yes, sir. Audible. Satish, sir. Good evening.
Yeah, good evening, sir. Sir, on the curiosity I'm asking, suppose we assume that we are having a commercial hydrogen vehicles on road, hydrogen IC engine vehicles. What would be the case of safety, sir? Will it be safer in mobility?
Yes, sir. It is definitely safe. No trouble in that because meaning the hydrogen, first of all, it is stored in the hydrogen tanks. Like we have got CNG tanks in the kind of market. You see the vehicles running with CNG tanks. Of course, there are a lot of CNG autos, CNG cars are there, which you see when you open the rear door of the car, luggage space, where you see the CNG tanks, right? So it will be similar to that. And hydrogen, yes, and it is the CNG tanks are at 200 bar pressure. The hydrogen that we are going to have will be at 350 bar, slightly higher pressure than the CNG. And also in future it may go to 700 bar hydrogen, right? Still it is safer because the hydrogen tank, the storage tanks are tested and they have been designed for that particular purpose. And the tanks, the advancement in technology for the tanks, they are not going to rupture or they are not going to blast like that. So if there is a kind of big accident or something, also there is a protection inbuilt in that, meaning suppose if there is a pipe broken, then the gas can escape very fast, right? So there is but a safety system in place, fail safe design we call. There is excess flow valve that will actually stop the complete system. Whenever there is a flow rate more than the specified limit, it will stop the system. Therefore, the hydrogen is always protected inside the tank itself. Also, the valves, all the valves are electronic valves. Whenever there is a voltage not present, then the valve is closed. The hydrogen is stored in the tank itself. Hydrogen is not given outside. So therefore, all the kind of required safety is ensured. Therefore, hydrogen vehicles are safe to operate. No trouble. Is that answering your query, sir?
Yeah, sir. Well answered, sir. Thank you. Thank you, sir.
Thank you. I just kept my presentation part a little bit short itself, so that we can have more interactions. That's the reason I kept it a little short. Hope.
Excuse
okay.
me, sir.
So,
sir, I ask one question. It's also from curiosity only, but my question is related to emission. Sir, you are claiming EVs are emitting lesser emission. Okay, but what I understand is from 2015, new vehicles emitted equal or lower exhaust emission when compared to non-exhaust emissions. Non-exhaust emissions in the means emissions from the brake system, tires, and the road interface. Okay, so with the heavier battery packs included in the vehicle is becoming more and more weighter, which leads to more and more non-exhaust emission. That is why the upcoming Euro 7 norms is going to give more stringent norms towards the exhaust emission, non-exhaust emission, rather than the exhaust emission. So how you are claiming EVs are having lesser emission? Here I am talking mainly about the non-exhaust emissions, sir. Please, can you able to tell?
Yeah, sure, sir. Actually, this is actually debatable point. And thanks for asking that. Non-exhaust emissions in terms of the tire wear or the kind of dust that is going, the rising all that, and also the kind of the probably upstream emissions in terms of producing the battery. What are the emissions? Or when the battery is life cycle is over, how do we going to recycle it? So these are the emissions that we are talking, non-exhaust emissions in terms of. So, but these definitely the policies like what you are telling, BS7 norms, non-exhaust emissions, these kind of policies will definitely put check on that point, sir. I do agree what you are telling, but only one point I just want to differ slightly in terms of the brakes. Whenever these vehicles mainly, because these are having regenerative braking, when I apply brake in the vehicle, directly the brake shoe is not going to stop the vehicle. Instead, the motor is going to act as a generator, and the motor itself will stop the vehicle. Therefore, the energy is actually stored back to the battery as a regenerative energy. So therefore, the brake life actually should increase more theoretically. Should actually increase, and therefore the brake wear should be less. In that sense, the non-exhaust emission of brake wear should come down. But as the vehicle GWE is increasing, probably the amount of payload that I am carrying comes down. Therefore, per ton payload, if we see, it may slightly increase or it may decrease, depends on the exact calculations. But yes, I do agree for that point of non-exhaust emissions. And yes, we do hope that if the energy that is coming from for the charging the battery is coming from the renewable sources. Now only as a country we are thinking a lot of windmill establishing, the solar plant getting developed, so those aspects actually will bring it down. Probably in that calculation, non-exhaust emission calculation, where the energy is produced from, that also might have been considered. But considering currently most of the energy developed from the coal, so that gets probably added. It's my point of view for this, probably. So you can please that's what I would like to answer this. Sorry.
Okay, sir. Okay. Valid. I could understand, but only one point I want to differ. Regenerative braking, I agree. Whatever you tell, but the thing is that it makes the foundation brake not to be in use on major circumstances. So the pads they become corrosive, and we have to replace even without usage. That is a major concern, and this is a totally different area. Okay. Anyhow, thanks, sir.
I understood. Thank you, sir. Thanks,
okay, thank you, sir.
Sir, good evening. Am I audible to you?
Good evening, sir. You are audible.
Sir, thank you. Sir, actually, the limitation of the nuclear energy is that the waste which is coming out from nuclear energy, we cannot, you can say, it is not died. Means we cannot give out this waste coming out from nuclear energy. In the similar background, the battery which is working on lead as a main content. So lead output is also we cannot easily, you can say, what you can say, we cannot.
You mean?
We cannot
reuse
lead from the battery. So when we use the lead acid batteries in a huge amount, how we can manage that wastage after the battery is going to be died out? That is my question, sir.
Yeah, sir. Just coming to that point, the lead acid batteries, actually the batteries that we are using is the lithium ion, not really lead acid. And the kind of different chemistries in terms of NMC, LFP. These are the two main batteries being used: lithium ion, NMC, and LFP. But in future, the technologies kind of solid state batteries, those also may come. But currently we are using lithium ion. Whether the lithium ion batteries also, the government or the industry is thinking in terms of how to recycle, how to kind of give a second life for the battery. those aspects are going on. Even there is a kind of a portal where we should we are, as a OEM, is mandated to recycle as well. As a producer, even if we import, we have to recycle that. So that probably will offset this particular issue, if at all anything is there. Is that answering your query, sir?
Okay, sir. Okay, thank you.
There is a query in the chat. Availability wise, which type will be better? Venkatesh sir is asking, availability wise, which type will be better? Meaning fuel availability or something like that. If your query, it depends on the what purpose. Like if I am going for a two-wheeler, or if I am going for a car, or bus or truck, it depends on that, sir, probably. And also as the economy is developing, as the infrastructure is developing day by day, we need to see kind of availability in terms of the charging stations or the fuel. In my view, if you ask specifically to me, in my view, it is possible that the charging infrastructure and hydrogen infrastructure both will be available equal, in my view, and depends on my particular application. I may choose the exact fuel that I am going for. So this is the answer that I have at this point of time for that query. So, but all these advanced technologies, except battery electric vehicles, remaining all, the battery electric vehicles to some extent has got a lot of maturity, but the hydrogen fuel cell vehicle or hydrogen IC engine vehicles, both are in kind of testing phase. Battery electric vehicle also, you see, for example, a lot of companies now opting for the battery electric vehicles for their staff transport, or the kind of whatever the commute that they do daily, because they can put the charging station at one location, and the bus goes and comes back to the charging station and do the charging. So these are the applications where currently it is being applicated, the battery electric vehicles.
Sir, I am Lohanathan. I have a query. Sir, in the roadside, I had seen that liquefied natural gas vehicles. Is it possible to liquefied hydrogen gas?
Yes, sir. The like liquefied natural gas, the hydrogen also can be liquefied, and the hydrogen available in the liquid form, meaning not in India, or I would say very less part, but it's available outside India. Yes, it will also liquefy natural gas vehicles like that. Hydrogen, liquid hydrogen also works, but only trouble with liquefied gases is it will become a cryogenic tank, meaning we have to maintain that particular liquid at kind of minus 160, minus 200 degrees temperature. So to maintain such a low temperature, the insulation that is provided, vacuum insulation, has to be very effective. And if the vehicle is parked overnight, there is a chance of vapor formation, and therefore the vapor will leak out. There is a kind of safety system not to increase the pressure of the tank. It will kind of exhaust it to the atmosphere. So if I park the vehicle, I may lose some of the fuel, not fully, definitely. Some percentage of fuel will be lost if I park the vehicle. But yes, that technology also is evolving. In my view, it will be less chance for the liquid hydrogen, but we don't know future how it will be. Chance of coming that as well.
Sir, I have one doubt, sir.
Thank you, sir.
Yeah. And coming to the liquefied, just adding to that point, why liquefied natural gas we are using, why liquefied hydrogen we should go. The main reason for going for the liquid is, in a liter, for example, in 1 liter of petrol, the energy, how much energy is there? In the similar way, 1 liter of compressed natural gas, 1 liter of liquefied natural gas, the energy amount will be very huge. The kind of, I don't have exact number right now, probably you can Google and find. It gets multiplied, the energy amount. So therefore I can carry more energy in the vehicle. So why somebody go for liquid is that to carry more energy in the vehicle, therefore I can travel more distance. So therefore, even in one fill can actually take 2,000 kilometers also. So for the liquid, that's why liquid is kind of attractive in terms of energy density. Yes, sir. Elumalai, sir. Yeah.
Sir, actually, I have one doubt, sir. Actually, sir, it is possible to mix hydrogen and methane. and it will be compressed in cylinder. That cylinder it is possible to use for vehicle, because this doubt is there for last 6 months. No one is paper also not available.
Okay, I'm also not very expert like you. Actually, the methane, what is the chemical formula? Is it having carbon?
Yes, sir.
Okay.
CH4, sir, and it is H2. Then both will mix, no, CH6 will come, sir.
Okay.
And actually, some of the paper it is available, like they are mixing and they are utilizing. They are not storaging.
Okay.
But my question is why? Because some of the company they are doing mixing process. But my question is why they are not using for vehicles, like how we are using for CNG and LPG. So like that, why they are not this mixing cylinder is like in hydrogen and methane, not why they are not using? That is my questions for the last 6 months. I am searching the answer. I am not able to find it.
Okay, nice to hear that.
And
Actually, you are doing a lot of
and
thinking.
in literature survey, what they mention is, sir, whatever the gases for mixing is possible, but they are using like continuously. They are not storing. If they are storing, what problem will come? That is my questions. And the storage will compressed in that cylinder, and that cylinder will replace for CNG and like we are using vehicle as a CNG. That is possible to replace. Then if it is replaced, means what are the problem will come? Like one of the paper they mentioned, like if you in road condition, if you go for up and down directions, it will burst. Some of the paper they told, and some of the paper they're telling for gaseous state it is possible to mix only like 12 hours. Then afterwards it is not possible. Like that some paper telling. But exact answer I'm not able to get, sir. I'm searching for last 6 months for this answer.
Okay, I think my view is that because carbon is there, it may not be attractive for the greener part of it. But why the other aspects that you told, those I don't know. We have to contact any chemical engineering expert. It may be present in this session. They can actually tell you. I'm not aware. Sorry for that. But in terms of vehicle use point of view, because it is having carbon content, then I may not be able to tailpipe emissions zero. We may not be able to make it. But our aim is now to go to tailpipe zero emissions. That's probably one answer I could give. But the mixing part, the kind of 12 hours that you told, the numbers, those I think the right chemical expert has to be contacted. Chemical engineering.
Okay, sir. Thank you, sir.
Thank you.
So we are reached the session 1. It's time to thank Mr. B. Mallikarajuna Rao, sir, AGM, Ashok Leyland Limited. Sir, actually for this session is so informative and it's an eye-opening session. You explained from the basic of fuel to the future. It's really very interesting and more informative. Thank you, sir, for spending your time and sharing your knowledge in respect of your regular busy schedule. Thank you, sir. Thank you. Thank you very much, sir.
Thank you, sir. Thank you all, sir, for the opportunity.